All right, getting ourselves prepped for quiz number 7. A couple of things to keep in mind up here at the top. Some of my students in regular, when we did some of this, forgot some of these things, so I'm going to stress them especially in this quiz preview. First things first, negatives underneath the radical. Better remember. Okay, take the I out. Here's the other thing. These are not quadratic equations like number 8, number 9. These do not have, Harty, plus minus with them. This is just going to be plain old 9i. The I gets rid of the negative, and the square root of 81 is 9. Done deal, simple enough. When I get here, there's a couple of things going on this time. I know I got to take an I out. That takes care of the negative. I know the square root of 64 is 8. Okay. So that gets me to 8i right off the bat. The thing I've got to remember here is it's a little bit of that old school division. This is a little bit of a review from before even. Remember, my root, when I don't see it, is 2 because it's a square root. And then just basically see how many times your exponent can be divided by your root. 2 goes into 8 4 times. So I've got x to the 4th. Now, 2 I know evenly doesn't go into 7, but it does fully go in 3 times, so I can get a y to the 3rd out. But that one that's left over, that one that's a remainder, is going to have to stay under the radical. So anytime it doesn't go in clean, whatever would be left over, or my remainder is, has got to stay under, and that guy's going to be done. So lots of things to really think about there. Breaking down your number, pulling out the I, and then doing some exponent rules stuff. Here's the one, though, that I'll have people, even though I'm going to say it, okay, do not FOIL these. That's a plus and a minus. This one we FOIL. This one, no, not so much. Just combine the like terms. 4 minus 7 is negative 3. Watch your signs. Negative 9 plus 5i is negative 4i, and I'm good. And we do really want you to have it in this form, because when we talk about standard form with this, typically you put the real portion first and the imaginary part second. So, I mean, it's not wrong, let's say, if you put negative 4i minus 3, the signs are still right, but it's just as kind of strange. Here again, do not FOIL, but do distribute that negative through, or subtract when you're doing this. So 5 minus 12 is negative 7, and 13 minus negative 3, I'd make that plus, so 13 plus 3i would be 16. Again, done, finished, don't make it complicated. So when I get to 5 then, now I got to think a little bit, because now I do need to FOIL this out. So when I'm FOILing, let's see here. So 2 times 4 would be 8. Outer would be minus 14i. Inner is 12i. And the end is 21i squared. But remember, I squared is negative 1. So that's the equivalent of me taking this I squared out and replacing it with negative 1. So negative 21 times negative 1 would actually turn this into positive 21. No I anymore. So now I can just combine like terms. 8 plus 21 is 29. Negative 14 plus 12 is negative 2, and that one's ready to go. Now, number 6. This is back when we had that big chart that I gave you that had I to the first, I to the second, I to the third, and I to the fourth on it. And we talked about how many times will something go in. So just as a reminder, again, I is the square root of negative 1. I squared, if I were to square both sides, the squared and the square root would cancel, so I'd just have negative 1. I'm going to skip one here for a second. I to the 4th would be I to the 1st squared, which is positive 1. And I to the 3rd would just be I squared times I, which is going to give me a negative I. Or you could write the negative negative square root of 1, but that's normally not how we write it. So those would be my 4. This is a small enough one. To be perfectly honest, you could just count through and be like 1, 2, 3, 4, 5, 6, 7. Oh, it's negative I, and go about your business. If it was something big though, like 57, again, what I would do is I would divide this exponent by 4, because that's how many it goes around before it starts over. So if I did 7 divided by 4, you know, it would go in once, but I have a remainder of 1, 2, 3. And that remainder would be the value that I would be using. So like, for instance, let's say I did, let me come up with one that's going to be different here. Let's say I did I to the 10th. So I'd say to myself, okay, so 10 divided by 4 goes in twice. I've got a remainder of 2. Oh, there's my remainder. This would be negative 1. Just to get you thinking a little bit more, even though that's still small enough where you could probably count all the way around and get to the same answer. Just something to consider. But you've got to have a little bit of a grip on those 4 to make that work. This is the one that gets people. The complex conjugate. Remember, to get rid of that imaginary value in the denominator, the complex conjugate tells me I multiply by its opposite. In other words, if this is minus, this becomes plus. If this was plus, this would become minus. And then I'm going to FOIL it out. So underneath here, I'm going to do that. Let's scooch this over a little. So, get those in. 5 times 1 is 5. My outer would be 15i. My inner is a single I, and then I've got plus 3i squared. And I'll come back and simplify that in a minute. I'm just going to do all my FOILing at once. Then to the denominator, my first is 1. And I start to remember that my O and I are going to cancel, but in case I forget, I'll go ahead and multiply it out. Plus 3i minus 3i minus 9i squared. So what my last step here is going to be is just some simplifying stuff. And remember, I squared being negative 1, basically it'll take whatever this is, this positive 3, and turn the whole value into a negative. Or minus 9i squared will become plus 9, because it's negative 9 times negative 1. Once I do that, I can simplify things up. So 5 minus 3 is 2. 15 and 1 is 16i. My positive and negative 3i cancel. And 1 plus 9 is 10. Now, if you do this solid of a job, don't forget the last little thing and then get nabbed for a half. If I have a value that's divisible into all 3 of my terms here, then I can reduce, but it has to be all 3. So in this case, since I can nab a 2 out of each of those, I need to do that. And if I forget, like I said, if I forget, that'd be a little deduction, but it's not going to be the end of the world by any means. 8, big thing on problems like this is I want to get my x term isolated as fast as I can. So here, I need to get the 5 out of there first. Notice I'm not doing square rooting yet. I'm still not doing square rooting. I need that 2 out of my way, so I'll divide that out. Now I'm ready to deal with this. So a couple things. Get my square root to take care of my squared. Gotta remember now I'm solving a quadratic. That 2 should be your kind of hint. There's 2 answers. So I've got plus minus. Negative radical. Take the I out. And when I break down 32, because the I takes care of the negative part, square root of 16 is 4. Square root of 2. So I got to remember the plus minus. I got to remember the I. Those are each take a half off issues if you forget any of those. So break it down, get the I out. That should help you there. Here, Two things I do not want to do on number 9. I do not want to distribute the negative 3, and I do not want to FOIL. I want to isolate this quantity, this set of parentheses. So I'm going to divide by negative 3. Once I've isolated this, and I can't minus the 1 now or anything fancy, those parentheses are in my way. So I'll square root it. Again, I've got plus or minus. I know an I is coming out because of the negative. So I've just got to break down the radical now. So square root of 9 is 3. That's going to come out with my I. 5 doesn't break down. It's got to stay there. And then my last step is just to minus the 1 over. But again, don't try to combine that with this. It can hang out on the same side of the equation, but they're not going to mix. And if for some reason it comes out as a positive on the right, I just don't need the I. But I'd still need to look at breaking that down. All right, completing the square to find the center and radius of each circle. So these are the ones where I've got to complete the square twice. So I'm going to get together my x terms with a mystery number, my y terms with a mystery number, and then again I move the 23 to the other side and add whatever values I added in for my x's. And some of you I found as I've been looking through homework can find ways to skip steps on this. So as long as you're getting to where you need to find your values, bless you. I don't care if you do that or not. But for those of us that are going to tackle it this way, remember, it's just this b term divided by 2 and squared. So in this case, we have negative 8 divided by 2, which is negative 4, and square it. And it happens to be the same thing for both of them. So both of these will be 16s. But again, I got to make sure I add that to the other side as well. Because now I can get it into each of their binomial forms, which is going to make my life a whole lot easier with finding my vertex. Excuse me, in this case, my center. I'm doing a circle, not a parabola. So x, whatever my b divided by 2 was, would go in there to make my, holy mackerel, Harty, slow down. To make my binomial term, those are both minuses. But then again, when I'm finding my center, it's x minus h. It's y minus k. So it's the opposite of each of those. So my center is going to be at 4, 4. And my radius is just going to be the square root of this. Because again, this is r squared. So the square root of 9 is going to be 3, and we're good. And I'm going to do that same thing on 11. So I got my x squared minus 6x and something. Got my y squared minus 2y and something. And this time, my constant's already on the other side of the equation, so just leave it there. Don't bring it back. So here, let's see. Half of 6 is negative 3. Negative 3 squared is 9. Negative 2 divided by 2 is negative 1. 1 squared is 1. Get those added in on both sides. We're ready to get into our binomial form. Again, it's half of my b is what goes here, so half of negative 6 is negative 3. Half of negative 2 is negative 1. I'm into my standard circle form. Take my opposites to get my center. Square root that to get my radius. And I'm off to the next one. And the only thing that'll change once I get down to 12 and 13 is going to be, what exactly I'm being asked for. Okay, solve by completing the square, simplified exact answer, show work. Okay, I already got my constant term on the other side. That's good. So what am I going to add to my 10x, which is going to get added over here. Half of 10 is 5. 5 squared is 25. And that adds to both sides. I'm ready for my binomial form, which again is just half of b. So half of 10 is 5. Square root, because I need to get that squared so I can dump those parentheses. Remember, again, just like up in numbers 8 and 9, this is a quadratic. There's two answers. And if I can break down the radical, I need to. No i's this time. Square root of 9 would be 3. Square root of 3. And then I'm just going to minus that 5 over. And this is my exact simplified answer. No decimals. Because the decimals, there will be some sort of rounding involved, and we want exact. So stick to the radicals, please. So let's see. We've done it with a circle. We've done it with completing the square in an equation. Now we want to get it in vertex form at the end. Now a reminder again on vertex form. Looks like this. So when I do it this way, and I've got this y to work with, I don't know what I'm adding to y yet. I'm going to figure that out in a second. But it's going to be the same thing I'm going to be adding to my x terms over here. Because again, when it's y equals, I have to isolate my x's by putting them in parentheses, not by getting them on a side by themselves. To figure out the mystery number, that doesn't change though. Half of 8 is 2. Half of 8 is 2. Woo! Half of 8 is 4. Squared is 16. There's a blooper I wish I could forget. So y plus 16. Let me get into binomial form here. Half of 8 is 4. I'm almost there. I just got this 16 to get out of the way. So when I subtract it over, 13 minus 16 is negative 3. So I've got my vertex form with my equation. Then my vertex, again, is just the opposite of h. The opposite of positive 4 is negative 4, but plus k. Don't change the k value. Leave it alone. So, not too shabby. Yes, sir?
Pretty sure you have the k value you changed in your answer on the board over there.
For which one?
Number 13.
Oh, dear. Whoa. Why did I do that? All right, over on the board, yeah, it needs to be negative 3. That isn't right, because it should be negative 3. Good catch. So I'll get that fixed up over there. But we see it's going to be right on here, so that's good. And then find the zeros, choices. You can type this into your graphing calculator and find the zeros, but there's a faster way. If I'm looking for zeros, I'm looking to see when this is going to equal 0. Well, since I'm always going to follow the golden rule of factoring, since I never forget that, I know that I can take a 3 and an x out of each of these. And then I'm left with x, because 3x times x is 3x squared. And 3x times 3 is 9x. And I'm just going to set each of those equal to 0, and that's going to give me my 2 zeros. Because typically, whatever the exponent is here is going to tell you the number of zeros there's going to be. Subtract my 3 over. And we're good to go there. But like I said, you could also do it with finding the zeros or finding the x-intercepts on your graphing calculator as well. Let's see what the back's got in store here. Solve using the quadratic formula. Notice no sight of a formula anywhere. That's got to be in your noggin. Negative b plus or minus b squared minus 4ac all over 2a. So basically, it's my x value of my vertex plus or minus the discriminant, under a radical, of course. So, all right. Opposite of b. Opposite of negative 12 is 12. Square root of b squared, so negative 12 squared is 144. Minus 4 times a, which is 1, so that'd still be 4, times c. And again, I'll write it out on the next one, but if you're going to do this part on the calculator, do the math underneath first, then do the square root. All over 2a. And this one actually cleans up really nice, because the square root of 64 is 8. Be cautious, please. Don't leave this. If you can split them, if the radical completely breaks down, well then get to it. 12 plus 8 is 20. Divided by 2 is 10. 12 minus 8 is 4. Divided by 2 is 2. If I can get exact answers, let's get some exact answers. That won't happen every time, but it can occasionally. Probably could have factored that one easier. This one, so again, opposite of b, so negative 6. So minus. And again, if I was going to type it in my calculator, it would look like something like this. But what I was saying before is whatever's underneath here, I would do before I do the square root. We talked about before how the parentheses can mess us up otherwise. So 36 minus negative 12 would be plus, so that's going to be 48. Don't be content. If you can break down the radical, you better do it. Square root of 16 to be 4, square root of 3. And again, this quiz is going to be based for a lot of you which grades you get on detail stuff. Like here, if you stop, here's another halfer. I can take a 2 out of each of these. Again, it's got to be all 3 of them, though. And we're good to go on that one. But again, only if it's all 3 terms, not just those first couple. Now this next one kind of sees how well we apply ideas. Describe a quadratic equations graph that has one real solution. Now if I were to draw a picture, my picture would look something like this. Because if it has one real solution, it only has one x-intercept. It only has 1, 0. You could even put that in there. You could say it has 1, 0 if you wanted to. If it has 2 real solutions, it just means it's going to have 2 x-intercepts. It'll cross that x-axis in 2 distinct places. And if it's too imaginary, my parabola is never going to cross the x-axis. So I would have no x-intercepts. And again, that's as descriptive as you need to get for me. Just use the word x-intercept 0, please. And don't just draw me a picture. Because describe, I don't agree here that a picture's worth 1,000 words. I think it's the other way around. I want the 2 or 3 words instead. All right. And now to a couple of issues on the last quiz. Factor completely. When there are 4 terms, pair those guys off. Pull out the greatest common factor for each pair. So I can take a 5 and an x squared out from my first pair. I got an x and a minus 7 left. Now if I do this right, when I do my factoring on the second one, I should have the same x minus 7 left. These both have a 3. 3x, 3 times, good deal. But you're not done. Got to simplify. And to simplify, I put together my greatest common factors. And I put together their common factored portion. Now I'm done. And again, some of these are to test to see how you're doing with a particular way of solving. So here it says solve by factoring. Do not use the quadratic formula for this. Shouldn't have to. I don't think these are really complicated. Everybody wants to be on the t squared side. That's where the party's at. So I need, let's see, two numbers that multiply to 25, but add to 10. Sounds like 5 and 5. I could even write t plus 5 squared if I wanted to. But here's the stressor, and it's underlined this time. Solve. If there's an equals, I need to know what the variable value is. Don't just stop at the factoring. If it just says factor, then you can stop at just the factoring. But otherwise, you have to actually solve it and get a value for your variable. Over here, same deal. Multiply to 4 and add to 5. Sounds like a 4 and 1 to me. But again, don't stop. Setting those equal to 0 in this case just means we're going to be changing signs. And again, two values because of my quadratic. The rest of this basically is just some basic do you know. So for instance, what's the vertex of the equation? Opposite of h, keep my k. Okay, nothing else fancy. What's the equation of the axis of symmetry? Remember, it's just the x value of your vertex. It's negative b over 2a. Well, here, the x value of my vertex is negative 4, so it's just x equals negative 4. Again, keep it simple. Or you could just look up and figure out the vertex on your calculator if you wanted to. Speaking of the calculator, Thor threw a water balloon upward, threw it, luckily they gave me the formula though, from initial height of 8 meters and initial velocity of 10 meters per second. Again, initial height, h sub o, v sub o is my initial velocity. So in this case, my equation is going to start with just the h. That negative 4.9 t squared is not going to change. I don't know anything about t yet. My velocity is going to be 10. And my initial height is at 8 meters. Okay, that's all I need as far as the equation goes at the start. Now when it starts asking questions, there's a couple of things that I can do. For the rest of this, I can choose, if I want to go into my calculator, type this in. Not that way though. Okay, so there's my graph. What's the height of the balloon after 2 seconds? Well, the height's my y. My time, in this case, would be t. So I could do one of two things. I can either hit trace and say, okay, what's it when x equals 2? Well, it's 8.4. Okay, 8.4 meters. Or I could go to the table, go to where x is 2, 8.4 meters. Or I even could, if I didn't want to play with the calculator at all, just plug in 2 for each of the t's and just solve it algebraically, and I'd get the same answer. So, lots of options here. Now, for my balloon to reach the ground, that's going to cause my h at the beginning to become a 0. Now again, I have choices. I could use the quadratic formula here if I wanted to. Plug it in, figure it out. I really don't think you want to try factoring this. But if I want to see when it hits the ground, I could find a 0. I don't care about this. Why do I not care about this 0? Yeah, it's negative. I can't have negative time anyway. So again, this is one where I'll trap my 0 in if I want to do it this way. So my left is just going to be above my x-axis. My right bound would be somewhere below it here, because again, it's a little bit to the right of that point. And then I'll get my guess. And again, my y value is the height. That e number basically is telling you it's 0. So it's going to hit the ground in about 2.66 seconds. Not a long trip. So this is basically what you're going to have on your plate when I see you again. So